We finished the chapter with surface areas of spheres. When we did volumes of spheres, I linked a video in the description below my video on volume to Dr. Tanton's beautiful derivation for the volume of spheres. And you can use the volume of a sphere formula to get the surface area of a sphere. I'm going to link again Dr. Tanton's description of how you can do that below this video. The end result, so all the other ones we did prove together. This one, there's no point in reinventing the wheel. The end result is the surface area of a sphere turns out to be exactly 4 times the area of the great circle. So the great circle, remember, is the circle, a circle that you can draw on a sphere that has the same radius as the sphere. So if this was the Earth, the equator would be a great circle. And exactly 4 of those is how much material you would need to completely cover a sphere. So the formula is 4 pi r squared. Now in class, when I ask students, okay, so what's the surface area of a hemisphere? The quick answer I get is 2 pi r squared, it's half. But that's not quite right, because this is part of the surface, so we need to include that. So the lower half of this sphere has a surface area of 2 pi r squared. But a hemisphere with a surface here is an extra circle that we would be adding on, so it's actually 3 pi r squared. But in either case, the nice thing you'll notice is all you need is the radius. If you know the radius, you can get the surface area of a sphere or a hemisphere. So here we go. Notice the directions don't say to round. So can you pause the video and get the exact surface area of a sphere with a diameter of 9 inches. And since the formula is 4 pi r squared and a radius is 4.5, half the diameter, 4.5 squared is 20.25, and 20.25 times 4 is 81. Exact answer, 81 pi inches squared. Piece of cake. Number 2, how about a hemisphere with the diameter of √5 yards. Trying to make it somewhat challenging. So one thing to be careful of is if the diameter is √5, the radius is not √2.5. Square roots don't work that way. The square root of 5 divided by 2 is not the square root of 2.5. That would work if it was this, square root of 5 divided by the square root of 2. If they're both square roots, we can combine them into 1 square root of 5 over 2, or 2.5. So these are not equal. These are equal. But what we want to do is we want to take the diameter and not divide by √2, just divide by 2. That can't be simplified any further than it is. So this is the radius we're going to be using. All right. So remember, the formula is 3 pi r squared. The radius I just showed you is √5 over 2. So to square a fraction, you square the numerator and you square the denominator. √5 squared is 5, and 2 squared is 4. And if it helps you to think of this as over 1, then think of it as over 1. Multiply the numerator together, you get 15 pi, denominator 4. That's it, 15 pi over 4 yards squared. Next one. What is the exact surface area of a sphere if the circumference is 15 meters? So, if you know the circumference, you can get the radius. Replace the circumference in our circumference formula. Replace circumference with what we know it to be, 15. To solve for the radius, divide both sides by 2 pi. So we get 15 over 2 pi. Couple things. You can change that to 7.5 over pi, but it is not 7.5 pi. That pi needs to be in the denominator. The other thing is, if we were going to be putting this into a calculator and rounding off, you have to be very careful when you square a number like that. On a calculator, you would have to type this number, if you were squaring that number, you would have to type it like this. Now, these directions today, they didn't say round off, so we're not going to be doing this, but I just want to remind everybody, squaring a fraction, so first of all, the fraction has to be in parentheses. Even on paper, this fraction has to be in parentheses to show that I'm squaring not just the numerator, but the whole fraction. But in a calculator, you would need an extra set of parentheses so it knows that the 2 and the pi are both in that denominator. So that would be tricky on a calculator, but we don't need to do that today. You may need to do that for your homework, be careful. 4 pi r squared is the formula. There's the radius, 15 over 2 pi. So again, I square the numerator, 225. Square the denominator, 2 pi squared is 4 pi squared. Numbers work out nicely here. The 4's cancel. A 4 in the numerator and a 4 in the denominator cancel. And also, if there's one factor of pi in the numerator, but 2 factors of pi in the denominator, meaning there's 1 pi upstairs, but there are 2 pi factors downstairs, then a pair will cancel, so we just have 1 pi left over in the denominator. So the answer is 225 over pi meters squared. And the last one is this. I'm just going to hold that because it's going to keep moving. What is the surface area of this sphere? So, I'm going to show you 2 solutions. Let's see which one you came up with. They're both correct. One would be formula for the surface area of a sphere is 4 pi r squared, so let's figure out the radius. Area of a circle, area of this circle is pi r squared. So I'm going to set 14, which is the area of that circle, equal to pi r squared. So to solve for that radius, divide by pi on both sides. To get the radius by itself, square root both sides. So there's the ugly radius I'm going to use, square root of 14 over pi. That's the number I substitute into my formula, 4 pi r squared. Now it works out kind of nicely because this radical and this square are inverse operations. So I really just wind up with 4 pi times whatever is inside there, 14 over pi. Something else nice is the pi's cancel. 1 upstairs, 1 downstairs, so the exact answer, 56 centimeters squared. But the faster way, were you on your A game today? Remember we started the video saying the surface area of a sphere is 4 times the area of that circle. I gave you the area of that circle. So why not just multiply it by 4? 4 times the area of that circle, 4 times 14, 56 centimeters squared. Have fun!